Hi, everybody. We're going to do right now 1.4 in applied discrete structures. And this is about binary representations of positive integers. That's, as you know, ones, they say computers are like strings of ones and zeros. And that's really what this is. The number system we have is what they call base 10. And the digits are all powers of 10 because 324 is 3 times 10 to the second power plus 2 times 10 to the first power plus 4 times 10 to the zero power. In strings of binary, when you have all the zeros and ones, the columns represent powers of 2. So the first column is 2 to the zero power, then 2 to the first power, 2 to the second power, and so on and so forth. And that's really what we're saying over here, that binary number system differs from the decimal number system in that units are grouped by twos, fours, eights, etc., as opposed to tens, hundreds, thousands, etc. Anyway, that is the group sizes are powers of 2 instead of powers of 10. And we're going to show you a very simple algorithm for converting a base 10 number, a decimal number, into a base 2 number. And let me just, the section goes through it. It gives you some computer ways to write it and all that. Let me just go through it in plain, I guess, basic English, if you will. So let's take a number, I don't know, 47. Actually, let's take a bigger number. How about 147? Doesn't matter. I just want to show you an example. So basically, you keep on you just continuously divide this number by 2. So this is 2 times. Let's see, 146 would be 73 times 73 plus 1, and then 73 is equal to 2 times 36 plus 1, and then 36 is equal to 2 times 18 plus 0, and 18 is equal to 2 times 9 plus 0, and 9, see what I'm doing here, is equal to 2 times 4 plus 1, and then 4 is equal to 2 times 2 plus 0, and 2 is equal to 2 times 1, times 1 plus 0, and then finally 1 is equal to, well, that's, well, no, I'm sorry. Well, we're done, because and 1 is equal to 2 times 0 plus 1. And now that means, drum roll please, that 147 equals, are you ready for this? Can you guess? Can you figure it out? Can anyone tell me what it's going to be? 147 is equal to 100,100,11, and I'm going to write here base 2. Oops. We always write the base, when it's how do I say this? When it's base 10, you don't bother writing the base, but when it's not base 10, you do write the base. Although in binary, it could be binary, we're going to write it so much it doesn't, But anyway, that's generally what we do. Anyway, so that is the algorithm. Very awesome algorithm, and the text goes through it. Now the question is, why does this work? That's an interesting question. Why does this work? I always learned a different algorithm, or just not even an algorithm, just like sort of common sense, not an algorithm, but well, I guess an algorithm. I don't know. You just take the high. No, certainly not really an algorithm. You take the highest power of 2 that's less than 147, subtract it. I get 19, and the highest power of 2 that's less than 19 would be 16, and subtract that, and I get 3, and then well, actually I shouldn't be doing it this way. I should be doing it this way. 19 minus 16 is 3, and then 3. Then the highest power of 2, which is less than 3, is 2. That gives you 1, and the highest power of 2, which is less than 1, is 1, because 1 is a power of 2. It's 2 to the 0, and that's it. We're done. And wait, I'm missing something here. 19, boy. Oh, hey, when I missed the whole video. What did I miss? So again, I look at all the powers of 2 that got subtracted here. I subtracted 128, then I subtracted 16, and I subtracted 2, then 1. So that means there's a 1 in the 128's column. There's a 0 in the 64. Now it jumps to 16. So that means there's a 0 in the 64 column and a 0 in the 32 column. There's a 1 in the 16 column. And then it skips 8 and 4. And there's a 1 in the 2 column and a 1 in the 1 column. That's the standard way I always learned how to do it. And that gives you the same number. That's the 1. That's the 128. That's the skip the 64, skip the 32. And that's the 16. Skip the 8, skip the 4, that's the 2, and that's the 1. So these are all the numbers that wind up getting sort of subtracted. That winds up being my final answer. So there are 2 famous ways to do this, and that's that is the conclusion of our video. It's been loads of fun, and we'll see you next time.